I'm Sushmita from Sri Venkateshwara College of Engineering. My teammates are Teja and Sushmita Das. This is a mini project topic named 4-bit CPU design with paging and stack management. Introduction. This project covers the design and implementation of a 4-bit CPU with paging and stack management. The ALU performs arithmetic and logical operations while the registers ACC, PC, SP and page table manage data, program flow and memory paging. The memory module supports 256 into 4-bit RAM divided into 16 pages, enhancing memory management. The CPU integrates the ALU registers and memory following a fetch, decode, execute cycle. The test bench verifies the design through simultaneous generating waveforms for analysis. This design demonstrates foundation CPU functionalities and advanced memory management techniques, providing insights into more complex CPU. So here we are going to write the two codes, that is the Verilog code and the test bench code. From that code we will get a 4-bit RAM CPU. Introduction to 4-bit CPU design. This presentation explores the design and implementation of 4-bit CPU with paging and stack management. The primary objective is to understand basic CPU functionalities and integrate advanced memory management techniques like paging and stack operation. Learning CPU design and memory management is crucial for developing efficient and scalable computing systems. The project provides a foundation for understanding more complex CPU architectures and their memory management systems. The significance of this project lies in its ability to illustrate basic CPU architecture and its integration with memory management systems. By building this CPU, we gain insights into how real-world processors handle data and execute instruction, laying the groundwork for more advanced CPU designs. So, in this presentation, we will design and implement the 4-bit CPU with paging and stack management. So, the next process is explained by my friend.
To see the arithmetic logic unit. The ALU is responsible for performing arithmetic operations like addition, subtraction, and logical operations, and or it takes 2-bit and 4-bit inputs A and B, and an operand code ALU dash of B to produce a 4-bit result and a carry flag. The ALU is a crucial component of the CPU as it handles all the tasks. For the example, if A is 3 and B is 2 and the operation is addition, the ALU outputs 5. This model ensures that the CPU can perform a essential arithmetic and logical function. The register model includes ACC stores the results of operation. PC, which is program counter, stores the address of the next instruction. Stack pointer, which we call as SP, points to the top of the stack. Page table registers manages the memory paging by storing the correct page addresses. Next topic is memory with paging. The memory module includes a 256 into 4-bit RAM divided into 16 pages, each with 16 words. This is the example for the paging. Paging is a memory management technique that allows efficient use of a memory by dividing it into the fixed size pages. The pages table register stores the correct page addresses, which along with the address within the page access memory efficiently. This approach reduces the memory fragmentation and improves the speed of a memory access. For example, a data access request will be transferred into page and a word addresses within the page, ensuring organized memory management. Content. Memory architectures. Explanation of the 256 into 4-bit RAM divided into 16 pages with 16 words each. Paging concept. How paging helps in a efficient memory management. Page table. The role of a page table register in handling memory accesses. These are the concepts which we can see in our program and how we are dealing with memory with paging. Thank you.
So now I am going to explain about CPU top module. The CPU module integrates the ALU, registers and memory. It follows a fetch, decode, execute cycle to process instructions. This ALU performs computations, the register hold the data and control flow information. And the memory module manages the data storage and retrieval using passage. The instruction cycling inverse fetching is the instruction instance from memory, decoding it to determine the operation and executing it using the ALU and registers. For instance, an instruction to add two numbers will involve fetching the numbers, performing the addition in the ALU, the storing and result in the SCC. ALU. ALU means Arithmetic Logic Unit. In this, component performs arithmetic and logic operations. It receives inputs from the accumulator SEC and memory performs the specified operation which will give it is perform the that operation only and sends the result back to the SEC. Registers. The registers include the accumulator SEC, program counter PC, stack pointer SP, and page table register. The PC directs the flow of instruction execution. The SP manages the stack and the page table register facilities memory paging. So the next method is fetch, decode, execute cycle. So here example instruction execution. Instruction add SEC MEM PC, which is what is fetch. Fetch is the CPU fetches the add instruction from memory. Fetch means read, means the CPU reads the instruction from the memory. Decode. The instruction is decoded to determine it's an addition operation involving the ASCC and a memory location. So what is decode? It is used to determine what operation we are going to do. Means it is determine the operation. So next is execute. The ALU adds the value in the SAC with the value fetched from memory. And the result is stored back in the SAC. So execute it. What it will do? It is adds the value in SAC and it store the result in SAC. Control logic. The control unit generates the necessary control signals to coordinate the operation of the ALU. Registers and memory ensures that the correct data is routed to the ALU. The results are stored appropriately and the PC and SP are updated needed.